Hello students, hope you are doing well. In this video, we are going to discuss campus design consideration part 3 of unit 3, designing basic campus and data center network for the subject enterprise network design of B7 semester IT, University of Mumbai. In previous two lectures of campus design consideration, we have covered designing an enterprise campus, network application, and environmental characteristic and consideration, then infrastructure device characteristics and consideration we will going to discuss today. In this, we will cover convergence times, multi-layer switching and Cisco Express forwarding, IP multicast, quality of service consideration in LAN switches, load sharing in layer 2 and layer 3 switches. Infrastructure device characteristics and consideration. Network and user devices are commonly connected using switch technology rather than using a shared media segments. Switch technology provides dedicated network bandwidth for each devices on the network. Switch network can support network infrastructure services such as quality of services, okay, then security, then management. So these are very important things. But in case of shared media, it is not there. So we always use switch media infrastructure. In the past, LAN switches were layer 2 only device. Okay, what is the meaning of layer 2 only device? It is operated at MAC address. So data link layer, that is layer 2 switching, supports multiple simultaneous frame flow. This is also one thing that the unit of data flow is frame flow. Multi-layer switching performs packet switching and several functions at layer 3 and at higher OSI, that is open system interconnection layers, and can effectively replace router in LAN switch environment. Deciding whether to deploy pure data link layer switches or multi-layer switches in the enterprise network is not a trivial decision. It requires huge effort and full understanding of network topology and users deployment. So the difference between data link layer and multi-layer switching is the type of information used. Okay, in data link layer we are using frames. Fine. So inside the frame to determine the correct output interface, that is also one thing. Then data link layer switching forwards frames. Clear? It forwards the frame based on data link layer information. So this uses the MAC address. It means inside that frame MAC address based addressing is there. So it is colon separated 48-bit long address. Okay, whereas multi-layer switching forwards frames based on network layer information such as IP address. Okay, these are also known as logical address. Fine, and these are dot separated like 192.168.1.1. I'm talking about IP version 4. If it is IP version 6, it is also colon separated, and this IP version 6 is 128-bit long. Multi-layer switching is hardware-based switching. Fine, multi-layer switching means multiple layers are involved here. So inside that, routing is multi-layer. It is hardware-based switching and routing integrated into a single platform. So that is hardware-based switching and routing. Both are integrated. Okay. When deciding on type of switch to use and the features to be deployed in a network, these are the factors. First factor is infrastructure service capabilities. The network services that organization requires, like IP multicast and quality of services and so on, these are the infrastructure service capabilities. Now come to size of the network. Fine. So how the network is segmented and how many end devices will be connected based on traffic characteristic. So traffic is important thing. Then convergence time. So this is the maximum amount of time the network will be unavailable in the event of outage network outage. And the cost is very important thing, very well. The budget of the network infrastructure. So note that multi-layer switches are typically more expensive. Multi-layer switches are typically more expensive than the layer 2 counterparts. Okay. However, multi-layer functionality can be obtained by adding cards and software to the modular layer 2 switch. Fine. Convergence time. Loop prevention mechanism in a layer 2 topology cause the spanning tree protocol to take between 30 to 50 seconds. Okay, if loops are there, so we need to create this loop. We need to convert this loop into tree so that no looping will be there. So it will take 30 to 50 seconds to converge. To eliminate STP convergence issue, because this is very big time in the campus core, all the links connecting core switches should be routed links, not VLAN trunks. This is also limit to broadcast and failure domain. In the case where multi-layer switching is deployed everywhere, convergence is within second. Okay, depending on routing protocol implemented, because all the devices detect their connected link failure immediately and act on it promptly. So this is very important thing while we are using multi-layer switches. In the mixed layer 2 and layer 3 environment, the convergence time depends not only on the layer 3 factors, including routing protocol timers such as hold time and neighbor loss detection. In layer 3, hold time and neighbor loss detection. Okay, so these are the factors, one factor. So what we need to do, but also on the STP convergence. Okay, so this is layer 3, and in case of layer 3 hold time and neighbor loss detection. And in case of layer 2 switching, what we need to do, what we need to perform, like looping is there, so we need to overcome from looping environment. This is spanning tree protocol. Okay, using multi-layer switching in a structured design reduces the scope of spanning tree domains. It is common to use a routing protocol such as Enhanced Interior Gateway Routing Protocol. Enhanced Interior. So this is example of STP, and this is example of EIGRP, that is Enhanced Interior Gateway Routing Protocol, and this is example of OSPF, Open Shortest Path First Protocol. These all protocol is used to handle load balancing, redundancy and recovery. What are the things? First thing is to handle the load balancing. Okay, load balancing. Second thing we need to handle is redundancy. And third thing is recovery in what? Campus core. So all these protocols you have already learned in your previous semester. Okay. Multi-layer switching and Cisco Express forwarding. In previous unit, we have already seen that the term multi-layer switching denotes a switch's generic capability to use information at different protocol layers as a part of switching process. The term layer 3 switching is a synonym for multi-layer switching in this particular context. So this multi-layer switching is also denoted by layer 3 switching. The use of protocol information from multiple layers in the switching process is implemented in two different ways within Cisco switches. First way is called multi-layer switching or MLS. and the second way is called Cisco Express Forwarding. So this is first technique, multi-layer switching, okay, and this is second technique. Now let us discuss multi-layer switching. Multi-layer switching, its name already suggests that this allows switching to take place at different protocol layers. Fine. So switching can be performed only on layer 2 and layer 3, or it can also include layer 4. Therefore, it is colored in green. So, or it can include layer 4. Multi-layer switching is based on network flows. So, what is network flow? Network flow is a unidirectional sequence of packets between source and destination. Flow can be very specific. Specific means source and destinations are always included. So, like a network flow can be identified by source and destination IP address, protocol numbers, and port numbers, as well as the interface on which the packet enters the switch. There are three major components of multi-layer switching. These are MLS root processor. It is denoted by MLSRP. The MLS enabled router that performs the traditional function of routing between subnets. Traditional function of routing between subnets. Next is multi-layer switching engine, MLSSE. The multi-layer switching enabled switch. All these are multi-layer switching enabled switch that can offload some of the packet switching functionality from this MLS root processor. Okay, some of the functionality from this processor, and now multi-layer switching protocol which enables both the things. Fine, it is used by MLS RP and MLS SE to communicate with each other. To communicate with each other. For communication, there are requirement of certain rules and regulations and policies. So for this purpose, we use multi-layer switching protocol. Pure multi-layer is an older technique. Pure multi-layer is an older technique. Okay. Used on the Catalyst 5500 switches with a root switch module. It is manually configured as MLS RP. So root switch module, and it is manually configured as MLSRP. Okay. Now come to second thing, that is supervisor module. Supervisor module, and it is configured as MLS SE. Fine. The first packet of the flow is routed by MLSRP. This is responsible for first packet. Then, whereas the MLS SE records, this MLS SE records or caches. What is caches? All the flows. All the flows or header information, all subsequent packet in the identical flow are hardware switched by MLS SE. So most of the Cisco's modern multi-layer switches use Cisco Express forwarding based multi-layer switching using hardware integrated in the switch platform. So because this is traditional or old technology, now Cisco Express forwarding is very common. So here some of the important thing like forwarding information base, multiple adjacency table entries. These are common things which is used at different layers. Cisco Express Forwarding like MLS aims to speed the data routing for forwarding process in a network. However, the two methods use different approaches. Cisco Express Forwarding use two components to optimize the lookup of the information required to route packets for the forwarding information base for layer 3 information. Okay. Now, and the adjacency table for the layer 2 information. Cisco Express Forwarding creates an FIB by maintaining a copy of forwarding information contained in the IP routing table. The information is indexed, so it is quick to search for matching entries as packets are processed. Whenever, whenever the routing table change, the FIB is also changed. That is always contain up-to-date path. A separate routing cache is not required. Fine. The adjacency table contains layer 2 frame header information, while letter contains what are the information? This FIB contains, because it is layer 3, IP routing table information. And the next adjacency table, it contains the frame header because it is layer 2. So it consists of frame header information, including next hop address. Including what? Next hop address. For all FIB entries, each FIB entry can print point to multiple adjacency table entries. For example, if two paths exist between devices for load balancing. After packet is processed and route is determined from the FIB, the layer 2 next hop and header information is received from the adjacency table and the new frame is created to encapsulate the packet. Cisco Express forwarding can be enabled on a router like Cisco 7600 series router or on a switch with layer 3 functionality like Catalyst 6500 series switch. So these are the important things associated with multi-layer switching and Cisco Express. So again, I'm going to summarize that multi-layer switching deals with multiple layers. Mainly these are the two layers where switching is performed, and sometimes layer 4 is also included, and this is done by network flow, which is a unidirectional sequence. And again, there are three major components of MLS. First is MLS root processor and second is MLS switching engine. The MLS switching protocol is associated with how to schedule these things, okay, for communication. So this guides how to communicate between these two protocols, and then come to the MLS history. Pure MLS, this is hybrid or means hybrid kind of MLS. Pure MLS is the older implementation. There are two modules, root switch module. It is like MLS RP, fine. And second is supervisor module. So this is MLS SE, and this MLS SE first packet whenever this is going to start. So first ever packet is root switch from root switch module, and next or subsequent packets are from supervisor module. This is MLS SE. Okay. Now come to Cisco Express forwarding. So there are two important things. First is forwarding information base and second is multiple adjacency table entries. So this FIB is associated with layer 3. Therefore, it maintains the routing table. For L2, multiple adjacency tables are there which stores frame header information and next hop information or next hop address. Okay, so there are two different things we use, like Cisco 7600 series router or Catalyst 6500 series switches L2. IP multicast. A traditional IP network is not efficient when sending the same data to many locations. The data is sent in unicast packets and therefore is replicated on the network for each destination. For example, if a CEO's annual video address is sent out on company's network for all employees to watch, the same data stream must be replicated for each employee. Obviously, this would consume many resources including precious WAN bandwidth. IP multicast technology enables network to send data to a group of destinations in the most efficient way. The data is sent from the source as one stream. This single data stream travels as far as it can in the network. Devices replicate the data only if they need to send it out on multiple interfaces to reach all members of the destination group. Multicast groups are identified by Class D IP addresses, as you know, which are in the range from 224 to 24.0.0.0 to 239.255.255.255. IP multicast involves some new protocols for network devices, including two for information network devices which host required which multicast data stream and one for determining the best way to route multicast traffic. These three protocols are first protocols is IGMP protocol. Okay, then second is Cisco Group Management Protocol, and third is Protocol Independent Multicast Routing Protocol. So let us see each one by one. So first of all, I'm going to describe IGMP and Cisco Group Management Protocol. Okay, this is Cisco Group Management Protocol, Cisco Group Management Protocol, CGMP, and this is IG. So how this is going to work? IGMP or Internet Group Management Protocol is used between host and their local routers. Hosts register with the router to join and leave a specific multicast group. The router then knows that it needs to forward the data stream destined for a specific multicast group to be registered host. In a typical network, hosts are not directly connected to routers but are connected to a layer 2 switch, which is in turn connected to the router. IGMP is a network layer 3 protocol. Consequently, layer 2 switch do not participate in IGMP, fine, and therefore are not aware of which host attached to them might be part of a particular multicast group. By default, layer 2 switches flood multicast frames to all ports except the port from which the same frame is coming or originated, which means that all multicast traffic received by a switch would be sent out on all ports, even if only one device on one port required for the data stream. Cisco therefore developed Cisco Group Management Protocol. This is related with grouping, and we need to modify and reduce the redundant information so that it will efficiently send the data. So it is used between switches and routers. The routers tell each of their directly connected switches about IGMP registrations. Okay, here CGMP and CGMP is shown, and then IGMP is above this router layer 2. Okay, and this is layer 3. So this is how we can use or we can perform. So Cisco Group Management Protocol, which is used between switches and router, the router tells each of their directly connected switches about IGMP registration and were received from host through the switch, or we can say that from host accessible through the switch. The switch then forwards multicast traffic only to ports that those requesting hosts are on, rather than flooding the data to all ports. Fine. So this is how we can maintain the flow. Switches, including non-Cisco switches, can alternatively use IGMP snooping to eavesdrop on the IGMP message sent between routers and hosts to learn similar information. For example, we can see in this diagram the interaction of these two protocols. Host A and D register, fine. Host A and D. Host A and D register for something using IGMP to join the multicast group to receive data from server. So this is the server, and from here it is registered using IGMP protocol. When the router forwards the multicast data to the host, the switch ensures that data goes out of only the ports on which host A and D are connected. The ports on which host B and C are connected do not receive the multicast data. So this is how we maintain the information. Fine. So this red line shows the multicast data, and this is it is flow between A and D, not the other, because it is this router is responsible for multicasting the data, but CGMP is also it is able to ensure that it must reach to the desired destination. Now come to protocol independent multicast routing protocol. So what is that? Protocol independent multicast routing protocol is used by routers that forward multicast packet. The protocol independent part of names indicate that PIM is independent of unicast routing protocol like EIGRP and OSPF routing in the network. It uses the normal routing table populated by the unicast routing protocol in its multicast routing calculations. So this is PIM. Very important thing is that EIGRP, OSPF and other protocols are called unicast routing protocol because they are used to create and maintain unicast routing information in the routing table. And we know that they are used multicast packet or broadcast packet in the some protocol to send their routing update traffic, and it is that a variant of OSPF called multicast OSPF support multicast routing. Cisco routers do not support multicast OSPF. Okay, Cisco do not support Cisco router do not support multicast routing. Unlike other routing protocol, no routing updates are sent between PIM routers. So this is no problem, not an issue. When a router forwards a unicast packet, it looks up the destination address in its routing table and forward the packet out of the appropriate interface. However, when forwarding a multicast packet, the router might have to forward the packet out of multiple interfaces. towards all the receiving hosts. Multicast enabled routers use PIM to dynamically create distribution trees that control the path that IP multicast traffic takes through the network to deliver traffic to all the receivers. Like one live event is scheduled, okay? And if you want to show this live event to all the persons and the persons who are interested, so the traffic must be diverted to that particular place. So that is how we are using PIM. So here two things. PIM is operated on two types of distribution trees: source tree and shared tree. Two types of distribution trees: source tree and shared tree. So a source tree is created for each source sending to each multicast group. The source tree has its root at the source and has branches through the network to the receivers. Now come to shared tree. Shared tree is a single tree that is shared between all sources for each multicast group. The shared tree has a single common root called RP, rendezvous point. Okay, this has common point RP, and this is rendezvous point. Multicast routers consider the source address of the multicast packet as well as the destination address, and they use distribution tree to forward packet away from the source and towards the destination. Forwarding multicast traffic away from the source rather than to receiver is called reverse path forwarding. What is this? Reverse path forwarding, RPF. To avoid routing loops, RPF uses the unicast routing table and ensures that only one interface on the router is considered to be incoming interface for data from a specific source, like data received on one router interface and forwarding out another interface can loop around the network and come back into the same router on different interface. RPF ensures that this data is not forwarding again. So this PIM operates in two different modes. First is sparse mode and second is dense mode. The mode sparse mode is the mode this in this mode uses a pull model to send multicast traffic. Sparse mode it uses a shared tree and therefore requires an RP to be defined. Source register with the RP. Routers along the path from active receivers that have explicitly requested to join a specific multicast group register to join that group. This routers calculate using unicast routing table and where whether they have a better metric to the RP or to the source itself. They forward the join message to the device with the better metrics. So this is how sparse mode works, and this uses pull model. You must remember that pull model is used by the sparse mode. While in case of dense mode, this mode is obviously it uses push model that floods multicast traffic to the entire network. Dense mode uses source trees, routers that have no need for the data because they are not connected to receivers that want the data or other routers that want it. Request that the tree be pruned so that they no longer receive the data. Means the tree must be cut from that particular point so that it will no longer receive the data. Quality of service consideration in LAN switches. A campus network transports many layers of application and data, which might include high quality video and delay sensitive data such as real-time voice, bandwidth, intensive application enhance many business processes but might also stretch network capabilities and resources. Network must provide secure, predictable, measurable, and sometimes guaranteed service. Achieving the required quality of services for managing delay variation like jitter, also known as jitter, bandwidth and packet loss information on a network can be the key to success end-to-end business solution. Quality of service mechanisms are techniques used to manage network resources. The assumption that high capability non-blocking switch with multi-gigabit backplane never needs quality of service is incorrect. Many network or individual network elements are oversubscribed. It is easy to create scenarios in which congestion can potentially occur and that therefore requires some form of quality of services. The sum of the bandwidths on all ports on a switch where and devices are connected is usually greater than that of uplink port. When the access ports are fully used, congestion on the uplink port is unavoidable. Uplink from building access layer to building distribution layer or from the building distribution layer to campus core layer most often require quality of services. Depending on traffic flow and uplink, oversubscription bandwidth is managed with quality of service mechanism on the building access, building distribution, or even campus core switches. So let us discuss each of the quality of service mechanisms. Quality of service mechanisms or tools implemented on LAN switches includes classification and marking. Packet classification is the process of partitioning traffic into multiple priority levels. So this is done by priority levels. Then only we can filter the things or classes of services. Information of the frame or packet header is inspected and the frame's priority is determined. Marking is the process of changing the priority. Marking is the process of changing the priority. Okay. Classification classifies the priority levels or classes and marking it it is the process of changing the priority. Fine. Or class of services. This is changing the priority or even we can say class of services. Setting within a frame or packet to indicate its classification. For IEEE 802.1q frames, the three user priority bits in the tag field, commonly referred as 802.1p bit, are used as cause bit. However, layer 2 marking are not useful as end-to-end quality of service indicators. Because the medium often changes throughout a network, for example, from Ethernet to a frame relay WAN, thus layer 3 marking are requested to support end-to-end quality of services. For IP version 4, layer 3 marking can be done using 8-bit type of service. Type of service is also very commonly used. TOS, type of service. Okay, so field in the packet header. Originally, only the first three bits were used. These bits are called IP precedence bits because 3-bit can specify only 8 marking values. IP precedence does not allow a granular classification of traffic. Thus, more bits are now used. The first 6 bits in TOS field are now known as DIFFSERV, Diff Serve Code Point, DSCP. Okay, DSCP, Diff Serve Code Point bits. So the two modules exist for deploying end-to-end quality of services in a network for traffic that is not suitable for best effort services, integrated services, and differentiated services, DIFSER. End-to-end quality of services mean that the network provides the level of service required by traffic throughout the entire network from one end to other. With INT-SERV, that is integrated service, an application request service from the network and the network devices confirm that they can meet the requested before any data is sent. The data from the application is considered a flow of packet. In contrast with DIFSERV, that is written here, DIFSERV, each packet is marked as it enters the network based on the type of traffic that it contains. The network device then use this making to determine how to handle the packet as it travels through the network. The DSCP bits are used to implement the diff-serve model. Next is congestion management. Congestion management using queuing and using scheduling. So let us discuss queuing first. Queuing separates traffic into various queues or buffers. Okay. The marking in the frame or packet can be used to determine which queue traffic goes in. A network interface is often congested even at high speed also. Transient congestion is observed. Queuing technique ensures that traffic from critical application is forwarded appropriately. Like real-time applications such as voice over internet protocol and stock trading might have to be forwarded with the least latency and jitter. Now scheduling. Scheduling is the process that determines the order in which queues are serviced. Now come to policing and shaping. Policing and shaping tools identify traffic that violates some threshold levels and reduces a stream of data to a predetermined rate or level. Traffic shaping buffers the frame for short time. Policing simply drops or lowers the priority of the frame that is out of profile. Fine. So these are the things associated with quality of services consideration in LAN switches. Now come to quality of services in LAN switches. When configuring quality of services features, classify the specific network traffic, prioritize and mark it according to its relative importance, and use congestion management and policing and shaping techniques to provide uh, preferential treatment. Implementing quality of services in the network makes network performance more predictable and bandwidth use more efficient. In this particular figure, where the various categories of quality of services may be implemented in LAN switches, building access, data link layer switching, building distribution, multi-layer switching, congestion management, policing and shaping, classification, marking, and congestion management. So these are the different parts where we have implemented things like classification, marking, congestion management, policing, shaping. Data link layer switches are commonly used in the building access layer. In the building access layer, so these are the data link layer switches. Okay, layer 2 switches. Now, because they do not have knowledge of layer 3 or higher information, these switches provide quality of service classification and marking based only on the switch input port or MAC address. For example, traffic from a particular host can be defined as high priority traffic on the uplink port. Multi-layer switches may be used in the building access layer if layer 3 services are required. So these are the multi-layer switches. Fine. These are multi-layer switches. Building distribution layer, campus core layer, and server farm switches are typically multi-layer switches and can provide quality of services selectively, not only on a port basis but also according to the higher layer parameters such as IP addresses, port numbers, or quality of service bits in the IP packet. These switches make QoS classification more selective by differentiating the traffic based on the application. Quality of service distribution in distribution and core switches must be provided in both direction of traffic flow. The policing certain traffic is usually implemented on the distribution layer switches. So policing is associated with multi-layer switches, okay, or distribution layer. In distribution layer, this is situated. So we have shown that multi-layer switches are used in, uh, it is used for congestion management and policing and shaping also. Load sharing in layer 2 and layer 3 switches. So layer 2 and layer 3 switches handle load sharing differently. So let us discuss first load 2 sharing. Layer 2 load sharing, because layer 2 switches are aware of only MAC addresses. Fine. They cannot perform any intelligent load sharing. Intelligent load sharing. In an environment characterized by multiple virtual LANs per access switch and more than one connection to the uplink switch, the solution is to put all uplink connection into trunks inter-switch link ISL or IEEE 802.1q. Each trunk carries all virtual LANs. However, without additional configuration, the STP protocol disables all non-primary uplink ports. This configuration might result in a bandwidth shortage because of the traffic for all the virtual LAN passes through the same link. To overcome this problem, the STP parameters must be configured to carry some virtual LANs ac- across one uplink and the rest of virtual LANs across the other uplink. Like one uplink could be configured to carry the virtual LANs with old numbers, whereas other uplink would configure to carry the virtual LANs with even numbers. So this is how layer 2 load sharing is done. Now come to this STP is spanning tree protocol already discussed. Okay, STP is spanning tree protocol. Layer 3 sharing. Layer 3 load sharing. Layer 3 capable switches can perform load sharing based on IP address either per packet or per destination source IP pair. The advantage of using layer 3 IP load sharing is that links are used more proportionally than with layer 2 load sharing, which is based on virtual LANs only. For example, the traffic is on virtual LAN can be very heavy, while the traffic is in another virtual LAN is very low. In this case, per virtual LAN load sharing is used. Even an old virtual LAN is not appropriate due to the dynamic nature of organizational application. Layer 3 load sharing is more appropriate. Layer 3 allows dynamic adaptation to link utilization and depends on the routing protocol design. Layer 3 switch also support layer 2 load sharing, so they can still apply per virtual LAN load sharing while connected to other layer 2 switches. So with this we finish this part lecture. We have discussed infrastructure device characteristics and consideration like convergence time, multi-layer switching, and Cisco Express forwarding. These two protocols are there. IP multicast, quality of service consideration in LAN switches, and load sharing in layer 2 and layer 3 switches. In next video, we will see enterprise campus design part 1. Thank you very much. Bye bye.